Bismillahirrahmanirrahim. Dear Honorable Speaker, special guest, research enthusiast participants, good evening. Welcome to your most expected research idea series. I am MD Masud Karim, Research Co-Ambassador of Gobeshok Hote Chai, BRBD platform from Jashore University of Science and Technology, Bangladesh. It's my pleasure to host today's program. Before diving into the lecture, I will introduce Gobeshok Hote Chai BRBD platform, its mission, vision, and activities. গবেষক হতে চাই বি রিসার্চার বিডি is an online-based non-profit open platform directed by some world-class scholars. They are tirelessly working to promote research and guide young researchers in Bangladesh. Its vision is to influence research in higher educational institutes for sustainable development all over the world. Mr. MD Sabir Hossain sir has initiated this novel effort. He is working as an assistant professor at the Department of Computer Science and Engineering of Chittagong University of Engineering and Technology, Bangladesh. We know that universities are the place for knowledge creation and distribution. However, the universities are going in the traditional way. Although the final year students do their thesis or project for obtaining the certificate, but research and publications at undergraduate level are rare. Mr. Sabir Hossain sir worked in a different way. By his effort, the second year students of the CSE department of CHUET have published more than 10 articles in international conferences and journals. This type of accomplishment is rare, not only in Bangladesh but also in the first world universities. This success provides him with more inspiration. Later, he created this platform to diverse this enthusiasm among all the students who are interested in higher studies and research. They are assisting researchers by sharing research-related resources such as books, papers, websites, conducting online, offline training courses, arranging seminars, workshops, webinars, research collaboration and supervision also, arranging internship opportunities although. Previously, they have conducted the country's first free, complete online training on how to become a researcher. This course covers the basic concepts, tools, and techniques required to become a researcher from zero knowledge. The recorded lecture on YouTube received more than 26,000 views within 8 months only. They have started the most demanding online free course titled Python for Research from any discipline on 31st April 2021. We know that selecting research ideas is the most important step in research methodology. However, finding a research idea or topic is a challenging job for the research enthusiast new learners. To assist them to finding ideas easily, we are organizing this research idea series. Research scholars from home and abroad of different disciplines will deliver lectures related to their research expertise or domain knowledge. Basically, speakers will share trending research topics, skills, tools, and techniques required to start research. His or her current past research project, publishing guidelines for a specific field. We have a plan to cover all the possible research areas in future. Now, I am going to introduce today's lecture and a speaker. It is the sixth lecture of the Research Idea series. The title is Research Scope in Energy, a Multidisciplinary Approach. The key highlight of this lecture are trending research in the energy, technique, tools, and skills required to start research in energy, speakers past and current research projects, recorded journals and conference in energy, publication tips, research collaboration. Today's honorable speaker is Dr. Engineer Imran Khan sir, who received his PhD degree in Management and Sustainability from the University of Otago, Dunedin, New Zealand in 2019. Since 2012, he has been working at the Department of Electrical and Electronic Engineering, Jashore University of Science and Technology, Bangladesh. He is a multidisciplinary researcher, and his research focuses on energy security challenges and transactions toward a low carbon and sustainable future. He is interested in exploring the interactions between technology, society, environment, and economy in relation to energy access and security. Detailed insights from those explorations can underpin new policy making related to research efficiency, negative climate change, energy access, and resilience. He has authored and co-authored more than 27 papers, and he has worked on 3 book chapters published by Elsevier, Springer Nature, and CRC Press, Toiler and Francis Group. Dr. Imran Khan has appeared in the top 2% list of world scientists for research impact based on the most recent single-year achievement in 2019 by Stanford University. He was also awarded University Gold Medal Award for securing first-class first position at undergraduate level of study. He is an editorial board member of journal at ASN Applied Sciences, Springer Nature, indexed in Web of Science in the discipline of engineering. He is also a special issue editor titled Engineering Topical Collection Sustainable Energy Trends in the Developing Economics, journal by ASN Applied Science, in Springer Nature, indexed in Web of Science, and in another special issue titled The Research and Innovations of Sustainable Energy in Journal of Sustainability, indexed in Scopus and Web of Science. He also received award recently from Just Research Association for being the uh, top four researchers in university. He is also reviewer at that many prestigious journal and societies. Before the lecture, there is a short notice. There will be a question answering session after the lecture. You can ask question by commenting on the live program on our page. Now I am requesting our honorable speaker to start today's lecture.
Okay, thank you, Masud, for your nice introduction. So before I start my actual lecture, there's a research scopes in energy and multidisciplinary approach. I'd like to share my a very short biographical case. Although Masud just explained or just described about it, but it's for your information who just missed his lecture. So I did my PhD from University of Otago in energy management and focused on demand side management and sustainability. And I'm working as an associate professor in the Department of Electrical and Electronic Engineering in Just, and I'm serving as an editorial board member for SN Applied Science journal and as a specialist editor for the same journal and MDPI journal. The name is Sustainability. And if you want to know more about me, so the website is there, so you can go and access there. So today's lecture, I'll try to focus on these four main topics. So first of all, the present status of energy research and future direction. So what is going on in this field, and what I'm doing at the moment, and then tools and techniques. So what kinds of tools and techniques are really helpful to explore the field in this research field, and then what I'm doing at the moment, and what I would say is like not I, just is my whole research team. So what we are doing at the moment and what to publish. So if we have some outstanding or interesting results, so which journals are really good fit for our result we publish, that's really a crucial thing. So we need to choose the specific and very I would say like renowned journal, so that our result can be catch a lot of experts view. So that's another interesting point I'll be discussing. So before going into details, we need to know what are the types of energy. So in general, we can say there's the different types of or forms of energy: mechanical, thermal, electromagnetic, electrical, chemical, and nuclear energies. So among all these things, I'll be mainly focusing on the electrical energy, and some part of might be the chemical one, because if we consider the bioenergy, that deals with this chemical portion, but mostly I'll be talking about the electrical energy. So this could be like electricity and the types of conversion, this sort of things, and it's related to the electricity generation and electricity distribution. So overall sustainability issues and how to control the demand, these kinds of things I'll be talking about. So these are the specific research scopes, or I would say these are the things at the moment I am doing, and more specifically or particularly, these are the topics that's really evolving in the field of energy at the moment. So electrical peak demand management, and sustainable electricity generation, sustainability assessment of electricity generation systems, prosumerism, renewable solution to energy poverty for the developing economies, and waste to energy. So there might be there are some terms that might be unknown or very new to you. For example, prosumerism. So I'll be trying to explain a little bit so that you can have an idea what is this and how these things are evolving in this energy field. So you might get an idea where to start the research from. Like a local prospect, or from like a global, that might be a global problem as well. So electrical peak demand, that's the first topic I'll be discussing. So before going to explain the demand side management, we need to know actually what is electrical peak or electrical peak demand. So if you consider these two figures here, you can see here this is actually the daily load curve from 3rd April 2021 for Bangladesh, and you can see this is actually the curve that's showing the national demand variation for 24 hours. So here from the midnight, that demand is like decreasing, and then at the mid of the day or just after the mid of the day, there's this tiny peak, and then in the evening you can see really a peak. So this is the peak, what we are saying, there's the peak and the peak in demand. So why this is really important? Because there's we always want to ensure that the demand must be served from the generation. But if this demand increase very suddenly and we don't have sufficient generation, then there might be a cutoff, or like the what we say is like load shedding or power cut. So to avoid that, we need to have some technology or have some scheme so that we can reduce this demand. And if we can reduce this demand, this kind of things, or this sort of power cut or demand reduction, a power cut, we can really avoid that. So how to do that? So that is, we are saying that's electrical peak demand management. So if you want to say what is electrical peak demand, so when electricity demand at a particular time or period of time exceeds normal capacity of the electrical network, peaks in demand are created. So actually you can see this is the normal demand. It's not really fluctuating a lot, but after like 6 p.m. you can see a huge variation in demand. So that is the peak that's created, and this is the common scenario in Bangladesh, and we can see these kinds of things every day. So, and another thing is that why these peaks are important to manage. So there are like a number of things we need to consider. First of all, we need generation capacity available to support this demand at that time. So we need some sort of power plants that only need to run at this peak time, and all the rest of the day it just sit idle. There is no generation from that power plant. So it is not an efficient way to produce power from that power plant. So that is the less efficient system. Secondly, this generation it's really costly, because when you are going to generate for a very short within a very certain or short period of time, then you need some sort of generation capacity. So you can use you can generate from like within 5 minutes or 6 minutes. So these kinds of generation technology either need to be gas fired or like oil fired. So and at the same time, this gas or oil is really expensive. For example, if you want to use the gas fired power plant, you in terms of cost, that is going to be higher than the gas, because we have gas in Bangladesh, so that is less costly, but we need to import oil from other countries, so that is costly. So when you will be using this oil-based power plant, you need to invest a lot of money. So if you can see this figure at the left, so you can see at this very top, you can see the oil is written there. So it is like daily energy curve and what types of fuel we used here. So this base demand is made normally by gas. Then you can see HVDC. So there is the power we imported from India. Then again gas, then some coal, and then again oil. So and then you can see some hydro here, and then its oil is here. So actually this peak, the actual peaks are really made by oil. So this is really expensive fuel to use to generate the electricity. And thirdly, when you are using this fossil fuel generation, you are generating a lot of greenhouse gases, so like carbon dioxide, sulfur dioxide, these kinds of things, and this is really harmful to the environment. So that's the issue with the sustainability. And Bangladesh is always really in a position that's too much vulnerable to climate change. So this sort of things, and if we continue to use these kinds of fossil fuel dominated electricity system, then it's going to be a very very bad situation. It's going to create a very bad situation for Bangladesh. So these are the main things. There are many others also. There are many other concerns about the peak demand management, but in general, these are the top most three reasons why we need to consider this peak demand. So there are different sectors in this electricity market. So you can see from this figure, like if we consider this country's figure for the financial year 2019 and 20. So we have the industrial sector, commercial sector, agriculture, others, and domestic. So definitely the major portion is going to this domestic sector, that is the residential sector. So if we want to use this demand side management, we need to focus on a sector that consumes most of the electricity, and in terms of Bangladesh, it is the residential sector. Like 57.02% is consumed by residential sector. So we need to really focus on this sector so that this demand can be reduced at the peak time. And recent research shows that this is one of my published paper, and you can see that we have the potential demand side management sector. For commercial is like 10%, for agricultural 20%, whereas for residential it is like 28.8%. And it is this demand side management includes like energy efficiency, conservation, these all sorts of things. So if we consider all these things together, the residential sector is the dominant one, where we can reduce the demand a lot. So demand side management can be a very good strategy to reduce demand during peak hours in residential sectors. So that is the potential, one of the potential sectors. There are many other sectors, and where we already reduced some demand. For example, in agricultural sector, we used to reduce the demand through solar powered pump, so that reduce also electricity consumption. And before 2013 or 2012, there was a circular that the farmers should use or switch on the pump after 11 p.m. at the night. So that was the one reason to shift the demand from peak hour to the off peak hour, so that we can have the sufficient generation at the time, so we can serve the maximum population or maximum consumers. So these kinds of demand side management is already there, but in terms of residential, it is really rare. For example, there are some conservation of conservational steps are taken, like don't use air conditioning system during peak hours, or reduce the or increase the temperature above 25 degrees, so there's the electricity consumption would be lower. So these kinds of things, but there is not actually very good designed or technically sound demand side management in the electricity market at the moment for Bangladesh, particularly for the residential sector. So what types of demand side management we can have and we can deal with? So here is a very brief description or very brief presentation. You can see the first one, this peak clipping. So as you have seen the previous slides, that the peak is like this type of peak in the evening in Bangladesh. So we can clip the peak. So there are some if we have some sort of scheme that can reduce the demand at certain level, that can we say is like peak clipping. And it can be done through load reduction, like if you can control the load directly from by switching off the air conditioning system, or for example the rice cooker for hundreds of household, then these kinds of demand reduction is possible. Then valley fitting is another one. So if you have sufficient generation capacity, then you can shift some of the demand from this peak hour to the off peak hour, so you can fit this valley, so it would be like more flat rather than this peaky in nature. Then another one is the same thing as I mentioned, is the load shifting, and here you can see the flexible load shape. So there are some loads, if you can observe that the load is or the demand is really decreasing, and you have the sufficient capacity, for example you have sufficient renewable capacity, and if you don't use that electricity, it's going to be wasted. So in that case you can shift, or you can move the load from off peak hour to peak hour, or it depends, like, so it's a flexible load, you can control this one. And strategic growth is another one, like you have different kinds of schemes for the household, so that you can control these loads. And conservation is like to motivate the people so that they can use less energy or less electricity during peak hours. So that's the conservation, and a lot of motivation is really required to do these kinds of things. So these are the general DSM types, or like, for example, I mean, to control the peak demand at residences. And this is actually a technical or technological term that used to reduce peak demand. So I won't be going in detail, because it really requires like hours of time to explain. But what is actually, we can say this demand response is spread in three different types: so time-based programs, incentive-based program, and energy-saving behavior. So this condition, or these types of demand-side management, deals with time-based, that is one of them is the time of use, just TOU. So like if you want to use one of your washing machine or one of your air condition like off peak hour, then there will be some benefit you will receive from the electricity authority. And these kinds of things, that's really related to the time controlling. And this another one is the incentive based program. So like, for example, direct load control. So if the electricity authority can see that there are several households in a residential feeder that is use a lot of air conditioning system during peak hours, so they have the control to switch off those big loads, so that the load can be reduced for that feeder. But definitely there will be a agreement between those households and the electricity authority that we can do that, and in return you need to pay less electricity bill at the time. So these kinds of things, but at the moment we don't have these kinds of facility in Bangladesh, because we don't have any smart grid or smart meter. Because when you want to control the load, like the direct load control, you must have a smart meter and smart grid, so that you can switch off, or you can control it from the electricity authority main office or distribution offices. So you can do that in that sense. And the last one is energy saving behaviors. That is really motivational. What is the present Bangladesh government or BPDB? They are really encouraging people through leaflet or through the website that use less electricity during peak hours, and increase the temperature above 25 degree for the air conditioning system, so that it can consume less electricity. These sort of things are energy behaviors. So if you want to know more, then the reference is there. You can go there and just have a look. But these are the things we have in demand side management strategy, but we don't have it in Bangladesh at the moment now. So in a nutshell, what are the future research scopes in demand side management? So which demand side management strategies are applicable to the residential sector of Bangladesh? As I mentioned, there is nothing, or at the moment just motivational things are there, but there is no technical demand side management studies in Bangladesh. So which one is applicable, why and how? So if you can try to identify which schemes or what types of things can be applicable in terms of, or in terms of residential electricity demand, that could be a very nice piece of work for future for Bangladesh to reduce the demand. So that's I'm just showing the very generalized future research scope, so that you can have an idea which from where we can start, or you can start considering considering the situation in Bangladesh. Next, the sustainable electricity generation. So before explaining these things, you need to know what is really sustainability. So sustainability actually a multidisciplinary concept. So you need to have a component or criteria from environmental side, and then social and economic side. So if you have a system that is able to coordinate equally between these three component or three criteria, that system can be said as a sustainable system. So in terms of electricity generation system, if a system, for example, an electricity generation system that has equal share or equal priority from environment, society, and economic, that such a electricity generation system can be said as a sustainable electricity generation system. So how it differs from the traditional sustainability decision making and sustainable, I mean the traditional decision making and sustainable decision making, what are the differences? So in terms of traditional decision making, this is fragmented and need based, what we have at the moment in Bangladesh. For example, we have a problem with a electricity generation system. So what is the problem? Let's solve that. So we don't really think about the integrated system, like if we solve this problem, what will be the other consequences, and what are the other faults that we need to really focus on, so that a system can be a very good combination between these three parts, like economy, environment, and society. So in terms of sustainable decision making, it is integrated and well coordinated system. And for example, if you can see in terms of most of the developing countries, like such as in Bangladesh, so you can see they are just focusing on economy, then environment, and at last the society. But if you want to have a sustainable system, then you have to prioritize equally. I like for example, economy, environment, and society. These all three things need equal contribution. So then the system can be said as a sustainable system. And if it, in case of electricity generation system, it should be sustainable at that moment. So these are the scenario for the sustainable decision making and traditional decision making. And in terms of sustainable decision making, it is like integrated and central. So you have you first of all you considered all the issues, then you communicated all these things, so at integrated way. So you are dealing with local, individual, global, regional, national. So you are dealing all the things at the same time. Whereas in terms of the fragmented one, there is this something happened in a local area, so you are just communicating with that and try to solve that one. Then something happened with the national one, then you are communicating with that one. So back and forth, these kinds of things. So that is not a sustainable solution, and it requires a lot of money, and it wasting our time, and it is not going to be a sustainable solution. So how we can assess the sustainability of a system, for example, the electricity generation system. So before saying that the system is sustainable, we need to follow some steps. So there is the identification of sustainability indicators. What are these indicators? Actually, as we mentioned, these environmental criteria, economic criteria, and social criteria. For each of these, we have different indicators. For example, the economic criteria, we have to consider the capital cost, then the maintenance cost, this sort of things. And for the environmental factor, environmental indicators, we need to consider the greenhouse gas emission from the electricity generation sector, then the water pollution, or the air pollution, noise pollution, these kinds of things from the power plant. And social factors would be like like job creation, how people will be benefited from that power plant, what is the inverse impact of this power plant, these kinds of things. So we need to select these indicators before assessing the sustainability of a power generation system. Then you need to select the electricity generation technology. So what are the technologies you are you will be using? For example, either gas fired, that is fossil fuel powered nuclear power plant, or renewable power plant. Then consideration of future electricity generation scenarios. For example, if you have the power system master plan, you must consider these things. So what types of generation you will be using in future, and then you need a technique, that is we normally use multi-criteria decision analysis, and through that we have sustainability assessment and identification of the sustainable scenarios. So through this process you have different scenarios, so you need to choose, then okay, this is the more sustainable one because it has all these components, or close to the result is really close to the sustainable criteria, so we can choose that one. So this is the overall process to assess the sustainability of electricity generation system. So what I did here is I considered the electricity power system generation plan, or what we call PSMP, power system master plan of Bangladesh, and I check the sustainability of this those plan of that plan. And you can see, first of all, I considered this technology, available technology. So I considered this biomass, wind, solar, hydro, nuclear, gas, oil, and coal. And you can see the sustainability indices. And sustainability indices, if a technology achieve like maximum 1, that is the sustainable one, and if it is like below 0.6, 0.5, so we can scale it accordingly, or we can say the sustainability status. So from this measurement, you can see for solar and hydro, they are really good in terms of sustainability in terms of Bangladesh, but in case of Bangladesh, but this hydro is really rare because we have like plain land, so hydro is not that much available in our country, but solar is there. So and this other is like biomass one, that is really increasing. So biomass includes like waste to energy. So there is a really potential field that could be used for electricity generation. And we have like future nuclear generation, although there are certain risks, but if we can manage this risk, this nuclear could be a good source of electricity. And definitely gas is another one, but we have limitation in gas technology, so we need to rely on some other factors. And you can see this oil and coal is really not very good in terms of sustainability assessment. And this one is showing the power system master plan and the sustainability indexes, so up to 2041. So here I started the analysis from 2008, and you can see after that 2020, then it is decreasing 2030, then 2035 it's increased a little bit, then 2040, and again from 2040 like 2041 it is decreasing again. So this trend is happening because you see, this is the generation scenario for future generation scenario, the power system master plan of Bangladesh in 2041. So this is the scenario in 2041, and you can see we are using coal there. So if we are using coal, and coal is definitely not a good fuel in terms of sustainability. So in these different scenarios, you can see like P3 RE20, that is like P3 scenario with 20% renewable, and P3 RE10 like this one is P3 with 10% renewable generation. However, all these things you can see coal is there. So if you have coal in your generation, then it's definitely going to be a less sustainable system. So over these scenarios and sustainability indices, you can see here I would say the best one is the P5 scenario. Why P5 is really good? Because you can see the gas is the generation capacity or the plant capacity is 55%. As you can see from here, the gas has really considerably good sustainability index 0.4. So that's why this one is showing better performance comparatively with others. And then this P3 RE20, there's renewable, 20% renewable, then 10% renewable. So these are the scenarios we assessed, or I assessed through the sustainability assessment for our power system master plan up to 2041. So why this sector is really important, and to what extent electricity sector sustainability could contribute to overall sustainable development of Bangladesh. That is really a crucial question. So what kinds of electricity sector, what type of change is really required to make this to make this electricity generation system as a sustainable one? That is really crucial question. So we need to identify some sort of solution so that we can make our electricity generation system as a sustainable one. And what are the challenges towards sustainable electricity generation in Bangladesh? So what are the main challenges that we need to face to make the electricity generation system as a sustainable one? So if you, these are the very, generalized question so that you can have an idea. So for at which sector we need to really focus to start with. So in terms of sustainability, these are the generalized research focus questions. The next thing, as I mentioned, the prosumerism. This is really one of the booming field in energy sector. So this is really happening in developed world, but interestingly, it is also present in our country. So that is in Bangladesh. So what is first of all, we need to know what is prosumer. Then we can come to the prosumerism. So you can see if you add these two terms, producer plus consumer, and then taking pro from here and consumer from here, it's a prosumer, and this process is known as prosumerism. So a consumer of energy who also produces energy to provide for their needs, and who in the instance of their production exceeding their requirements will sell, store, or trade the surplus energy. So this that is the prosumer. So in general terms, a person who has the capacity to generate his own electricity, and definitely it would be a renewable one, and at the same time he can use that electricity, and then he can sell or store that extra electricity or extra energy to others. So that is prosumerism. And if he want to sell that electricity, that we can say like electricity trading. So trading means you have like you are selling the electricity through the grid, and the other person who doesn't have that capacity, he will be buying that electricity. So this is called the electricity trading. So in Bangladesh, we have this kinds of facility, and a German company called Solskjaer, they use this technique. For example, this household has this electricity so solar home system. So he can generate electricity, and he can use this electricity for his own purpose. And if he has more than he required, then all these households are connected to each other. And for example, this household doesn't have any solar home system, but if they are connected with each other, like these kinds of connection, clustering connection, then they can, like if they need electricity, they can buy it from here or here from the grid, and they will have some sort of meter, they call it soul box, so that they can measure how much electricity they consume, so that they can pay the bill to the producer. So these kinds of things is really happening in Bangladesh, and you can see like in Shariatpur and some other places, they just established these kinds of prosumerism system, and this is really well functioning. But there are so many challenges. For example, these grids are really DC grid. DC means direct current grids. So you can't really transmit this electricity for long distance. So you have certain limitation, because DC current you can only transfer or transmit this current for certain distance due to the high loss in this electric wire. So that is one challenge. And then there are some like path distance. So you need some sort of algorithm. So for example, if this house is really need the electricity, but at the same time this household has the extra electricity, they don't have it. So you need to flow, you need to say, transmit the electricity to this household, but at that time you need to identify the shortest distance so that the loss could be minimized. So these kinds of things is really challenging. And another thing The main research challenge at the moment is the technical issues related to grid integration. So now it is not connected to the grid. So if you want to connect this microgrid to the national grids, so what will be the technical requirements? What will be the challenges? So that has not been discovered yet in terms of the low capacity solar panel, because we have the high capacity solar panel like above 3 kilowatt. You can connect it to the national grid. That is called net metering. That is available at the moment, and they are implementing this facility. But when you have the solar home system with like 100-watt capacity, 150-watt capacity, that is really a challenge to integrate it to the national grid. And the other point, as I mentioned, the DC loss. So how to minimize this loss and what could be the other techniques. So you can look at these terms and these problems to and try to identify or try to say, okay, these are the solutions. So these are the really generalized research, future research that could be done. Another point, or as I mentioned, the biomass. So waste is really one of the source of this biomass from where we can extract energy. So waste is a problem or a potential. It not nowadays it's really a problem, because you can see here in the figure we are not really good enough to put the waste or garbage in the right place. So this kinds of scenario is very common where dustbin is placed in anywhere in Bangladesh. So but this can be a good source of energy if we can manage it properly. So this is one of the scenario we can say. So waste generation rate ton per day, and we have like 6 cities in Bangladesh: Coxbazar, Dinajpur, Hobbiganj, Jashore, Mymensingh, and Sirazganj. And you can see the 2 different types of waste generation for waste generation in dry season and waste generation in wet season. And you can see for one is for the previous years like 2013, and another prediction for 2025. And you can see this predicted year is always increasing. So if we can use these waste to generate energy, there would be a good potential source for future energy, or even for future electricity generation. How? For example, we can consider the average waste composition in Bangladesh, and you can see most of the waste are really food and vegetable waste, with like almost 70% of that, and the rest of this not that much. So this is the composition of our Bangladeshi waste. So if we want to make this waste, or if you want to convert this waste to energy, that's we call waste to energy. We have different kinds of systems. So from waste to waste energy, we have like thermochemical system, biochemical system, and chemical one. So thermochemical one includes incineration, gasification, pyrolysis, biochemical, anaerobic digestion, fermentation, landfills with gas, and chemical. This one is really new, the esterification one. So considering the capacity, considering the fuel, considering the waste composition, that is this one, we have to select the technology from this one, this technology, which one is really good for our country. And research shows that this anaerobic digestion biochemical process could be a good one, because we have a lot of food and vegetable waste, and it contains a lot of water. So that's the reason we have anaerobic digestion that might be used for this purpose. And here you can see the overall process. So we have waste, then anaerobic digestion, we can generate biogas, and we can use gas engine that can generate electricity. Then we can use direct gasification technique, and then syngas and gas turbine, it can be converted to electricity. Another one, the incineration or combustion, then steam, and we can use steam turbine to generate electricity. So these are the ways we can use waste to generate electricity. But there is a problem, as I mentioned. Most of our waste are kitchen waste, that contains a lot of water. So you can see here, these black bars are the mainly the Bangladesh average waste composition. So for Bangladeshi waste, we have like 60.88% water in it, but we need the standard waste that could be used for a good source of energy if it has the water content less than 50. But in terms of Bangladesh, it has like, I mean, if you can use it for incineration or combustion or pyrolysis, then the water content needs to be lower than 50. And in terms of carbon or carbon, you can see that it should be greater than 25. Okay, for Bangladesh is like marginally greater than 25, like 26.06, and for ashes it should be below 60. And yeah, this one is really good, like it's less than 18, less than 60, so this is good for Bangladesh. And this channel diagram shows if a waste or combustible thing that falls into this shaded area, that can be used as a energy source, that can directly, that is combustible. I mean, combustible means that that fuel doesn't need any extra source of energy to burn it. So if any waste falls in this shaded area, that could be used as a energy source. But in terms of Bangladeshi waste, it falls in there, so it's really not good for incineration or pyrolysis, these kinds of things. However, as I mentioned, but these types of waste is really good for anaerobic digestion. So if we can use anaerobic digestion, that could be used for electricity generation in Bangladesh. So in terms of waste to energy generation, we need to focus on technical feasibility of waste to energy project or plant in Bangladesh. Is it really feasible? So that's really need to be identified. Theoretically, anaerobic digestion is good, but we need to check the technical feasibility. And the effective waste management collection scheme design. That is another challenge. We need to, if we want to make this waste as a energy source. So effective waste management and collection system is really required for Bangladesh to make it waste to energy conversion, our conversion process. So these are the general research, future research that could be done in waste to energy. So overall potential research field, I would say, to start with, peak electricity demand management in Bangladesh. What type of demand side management can be done in Bangladesh, or which is suitable, why and how? Then sustainable electricity generation and its aspect in Bangladesh, which electricity generation system or which combination or which how to optimize this electricity generation system there so that it can be a sustainable one. We can we can assess also that one. So, and energy poverty elevation through renewable energy solutions. So we have like solar home system, but is there any other source that could be used, like biomass or like biogas to elevate the energy poverty? Waste to energy generation potential in Bangladesh, and local problem identification of electricity generation system. So you can identify the local problem and then solve it, and that could be a good research work. So tools and techniques, as I mentioned earlier. So there are mainly three category. So first one is the simulation or experimental or survey. Like your tools could be, it depends on your research. So if you really want to design for example, a smart meter, then you need to do some simulation work first to check it, is it really working or not? Then you go for the experiment. So you need to implement the circuit. Then you can say that, okay, my system is working, and then you can, if it is really interesting or it is something new you have just invented, then you can publish it. Or another one is the survey work is really necessary when you need to identify the problem. So there are different kinds of problems at the moment in electricity sector. So if you want to identify the problem, is it really the problem is really there? So you need to survey it, like interviewing people or checking the systems, these kinds of survey. So that's another way of techniques to identify the problems or to research the problems. And then the next is the data analysis. So you have, for example, you have like experimental study, and you got a lot of data. So you need to identify or need to generate some results so that you can have an insight. So you can't really publish this raw data to the journal, but you need some sort of insight from your data. So you need to do some analysis. So there are mainly two types, quantitative and qualitative. So if your data deals with like numerical values, so you can use a quantitative analysis. Any statistical tools can be used. A qualitative one, like you have you interviewed the people, and then you need to add us you need to what I would say, like you need to sort out the main terms or terminology they used in their responses. Then you can use this qualitative technique, like the in vivo software, you can use it. So statistical analysis, so you can use like R for data science, MATLAB, SPSS, even MS, Microsoft Excel, or other similar software or tools you can use. But I would recommend, if you go for statistical analysis, learn this R for data science. This is really good, and it is free, so you can use this R. And if you have the capacity to learn R very well, then it could be a very good, I mean, it could be a very good skill for you for your future research or future career. So what what my research team doing at the moment, first of all, problem identification of renewable energy solutions, then residential demand profiling for Bangladesh household, peak demand management scheme design for Bangladesh, customizable smart meter development for energy monitoring at residences, and net metering. So these are the things that involves actually simulation part, and then experimental part, and survey as well. So for the first one, like problem identification of renewable energy solution, so this is the work. Actually, this one is conducted by one of my undergrad student. I repeat, it's one of my undergrad students. There's a Triple E department's fourth year, that's final year's student. That's MD Abu Saim. He conducted this work, and it's published in very recently in this journal. It's a very good quality journal. So what we did in what he did in this, so problem identification. So what are the really problems or benefits we are receiving from the solar home systems in remote islands? Like he conducted this survey in Hatia, the island. So what are the problems at the moment, and if these are the problems, then what could be the solution? So in this step, we just identified the problems. So, and the future research will be highlighting the solution. So these are the problem, and what could be the solution. So that's our next research we will be conducting. So to solve this problem, if we can solve this problem or not. And residential demand profiling for Bangladesh household, as you all know, the smart meter is recently just deploying in Bangladesh, but I wouldn't say it's that interactive like smart meter. So they are just saying it's a prepaid meter, but they has it has the potentiality, or it has like a smart meter feature, but they are not really using at the moment. So before designing any demand side management for Bangladesh household, we need to know what are the factors that really dominating in Bangladesh household. So, for example, you want to design a system or design a demand side management for a residence. Before doing that, you need to know what are the main contributors that is really contributing to the demand during peak hours. For example, if a household is using rice cooker or air conditioning system during peak hours, that two major appliances is really contributing to the peaks. So this sort of things, I mean, what are the factors that really contributing to peaks? This sort of things is just checked through an energy culture framework. That's one of the renowned energy culture frameworks invented by my PhD supervisors, Janet Stephenson and her team. So in this work, I just try to identify the dominating factors, so we can concentrate on that, and then we can propose solution for Bangladesh residences. And peak demand management scheme design, and in this work, and along with my two supervisors, we try to identify the demand side, to identify the factors that really contributing at different time slots during the day. So we have like, for example, during 6 p.m. to 11 p.m. at night, what are the main dominating factors? Then we consider like daytime one. So we just made the time is like 3 hours duration, then like 4 hours, 5 hours duration, and then try to search the factors using regression analysis. We call it like time segment and regression analysis, and that method is able to identify the dominant factors that really contributing to the demand. And this one is the smart meter development, as I mentioned. So we are trying to develop a smart meter that could really that could be really used to monitor the demand at residences at like 1 second interval or 10 minutes, 1 minute, half an hour, different kinds of intervals, so that we can say, okay, these are the loads that is really contributing, or that is really putting pressure on the overall demand that is generating from the household, or we can identify the load. So this is the prototype of our meter, and it is under trial at the moment. I have installed one in my household, and it is working very well, and we have future plans to future plan to establish in different households and to check their demand. Then we can say, okay, these are the factors, or these are the demand profiles, and these kinds of demand management could be established for the residences. In a long run, if we are able to use this smart meter, or we can install this smart meter in like thousands of houses, then we can say, okay, this is the we have the data, and we can see, or we can identify which are the loads that is really contributing the two peaks, and then the demand side management scheme could be designed considering those output or those loads. And net metering potential, is it a potential or problem? So at the moment we are analyzing different scenarios, like is it really good for our national grid, or it is really how we can use it, and it is really is it really a good one to go for sustainable development or green electricity generation? So that is under analysis, and one of my master's students is doing these things. So at the moment we are analyzing different scenarios. So after getting results, we can say, okay, is it really a potential or problem? If it is a problem, how we can solve it, and if it is a potential, how we can get it, or how we can establish it for the whole nation. So if you have these all these research done, then you need to identify a good journal to publish your result. Otherwise your research is not going to contribute, or there is no one noticing your research. So to reach the maximum people in your field, you need to identify a good journal. So these are the few renowned energy journals published by Elsevier, and you can see the first one is the Renewable and Sustainable Energy Reviews. Its impact factor is above 12, and then Applied Energy Conversion and Management, Journal of Cleaner Production, Renewable Energy, Sustainable Cities and Society, Energy Policy, Energy Research and Social Science. This is the journal where my undergrad student just published, so its impact factor is 4.771. So it's really a good start for him. And then Sustainable Energy Technologies and Assessment. So if you are able to publish just one paper from your undergrad thesis, or any time during your undergrad study, that could be a milestone for you to go for higher studies. So if you get some interesting result, then consult with your supervisor and try to publish it in a renowned journal. That would be really a milestone for your research career. And another advice is how to avoid predatory or fake journals. When you will get some interesting result, and if you don't know where to publish, you might be a victim of one of these predatory journals. I mean, so if you don't know how to identify the predatory journals, one of the very simple way to identify a journal, is it a predatory or fake journal, that is, use these two websites. This is Simago or Web of Science Calibrate Analytics, and you can just put the journal names. If it's just pop up the journal name, if it is there in that if it is indexed there, then you can say, okay, at least it is not a predatory or fake journal. You can publish it there, although it might not have any impact factor, but it's indexed. So if it is indexed, then it's you can say it's like at least it's not a fake journal. It's good to go. That's a green signal for, and it's very generalized. There are many other things you should consider, like impact factor. So if you have a journal, if it has a high impact factor, definitely that's a very good journal. And there is another category like Q1, Q2, Q3, Q4. So if a journal is Q1, that is quartile 1, so that's definitely a good journal and with impact factor. So go for that one. And if you don't have for undergrad research, I would say, like, if you can't really publish in a high impact journal, go for index journal, that is indexed in ISI or Web of Science. Check it from this website, and then you can find your find your journal. Is it really indexed journal or it is a predatory or fake journal? Predatory means they will offer you like, okay, submit here and you need to pay some publication fee and they will publish it. Not all the open access, the publication fee journals are mainly open access journal or predatory journal, but most of the predatory journal is kind of business, and they ask money, and they without without reviewing, they just publish it. So, two advice from my side: please try to avoid publishing in open access journals. Yeah, I'm saying it's open access journals unless they are renowned in the respective research field. If it's really a good journal and you find it in the Web of Science indexing and in like Simago, then you can publish it. But in that case, you need to have the fund so that you can pay the article processing charge. Otherwise, I would always say go for the open subscription journal, that is not open access one. And another recommendation: it is encouraged to publish in a good journal rather than in a conference proceedings, because if you have a publication or article that's published in journal and another one, and if your friend, for example, have a publication in conference and you both have the similar type of qualification, then be sure that the student or your friend who published in a journal is going to be considered or going to be prioritized more than you for any kinds of like research activities or scholarship. So first, if you want to publish it in a good journal, and if you want to publish it in a conference, then go for like the conference that is arranged by a good publisher like Elsevier, Springer Nature, or sometimes IEEE. But all IEEE conferences are not good, I would say. So so in that case, you have to consult with your supervisor. So these are the main two recommendations from me for publication purpose. So in a nutshell, how to get primary research idea. This is very generalized things, and this is for you, like for the undergrad student or anyone who want to start your research. Try to identify energy related local problems. So don't try to if you are not really able to access journals, because if it is not subscribed by your if it is not paid by your institution, you won't get the access. So in that case, the what is going on in that field and what are the really problems you are not aware about. So try to identify the energy related local problems. Think critically, is it really a problem? So that is important term. So you have a problem, but that might not be really a problem to solve. So think critically, is it really a problem, and is the problem well presented in the literature? For this case, you need to consult with your supervisor or a person who is really really expert in that field. And then, is there any solution to the problem in the existing literature? So if you identified a problem and your supervisor said, okay, yes, this is a problem, then try to find out, is it really solved in the literature? If it is solved, then you don't need to consider that problem, and you don't need to spend time on that. And then how to solve the problem. If that problem is not solved, then try to solve that problem. So that's the way you can get your primary research idea, like identification, problem identification. I would say, like from local problem identification to solution, and you might get a good publication from this research if you follow this trend. And we in Bangladesh, we have many different kinds of energy related problems. You just need to identify one and think critically. That is the second point, is really important. Think critically, it is really a problem or not. So that is the main point of all of this part. So think critically, is it really a problem? So thanks for your attention. I think I've just finished within time. Yeah, it's just a bit more, like 2 minutes maybe. Okay, thank you. If you have any question, now it's to the host.
Thank you, sir, for your valuable speech. Hope that it would be helpful for all the participants. Now I will read out questions from the comment box. Uh, there's a question from Masud Rahman. Will it be really suitable for Bangladesh? Maybe it's about the smart grid or the smart grid.
Will it be really suitable for Bangladesh? I mean, I really explained a lot of things. It's really difficult to identify which one you are talking about. So
Maybe
it'll be
say
good
it's
if.
about a smart grid system.
Okay, smart grid is if you invest a lot of money and we have the capacity. I mean, we need to. The first concern is that we need to invest a lot of money. If you are able to do that, then we can go for smart grid. That's not really. I would say it's doable. That's the answer. And then another question.
Another question is from Redwan Ali. Sir, is it feasible to have a 100% renewable energy based electricity system in Bangladesh in the distant
Uh,
future?
that's really good question. I would say it's like for even for many developed countries, 100% renewable is really tough. Why tough? When you are considering renewable energy, you have like wind power, hydro, solar, and they are all varying in nature. Like for example, you have wind capacity in your generation system, and you need peak time generation from suppose from wind. But at that moment, if you don't have sufficient wind speed, then you will not get any generation from wind. So that peak time generation will not be supported by that wind power generation system. So you need some sort of fossil fuel generation like oil fired generation or gas based power plant, so that you can instantly use it to meet the peak demand. But yes, it's like 75%, 80%, these types of even 90% electricity generation from renewable in developed countries, that is possible. In even in New Zealand, where I just completed my PhD, they have like almost 90% generation from renewable sources. But in terms of Bangladesh, 100%, I would say at this moment it is not really possible because we don't have that resources.
Another question from Mullah Ahmed Hassan. Sir, I am a first year undergraduate student of Tripoli. I am very emphasis to the research in the future. Are there any suggestions for me?
As I already mentioned, you how to identify the research question or how to identify the problem. If you are able to identify a good research question or good or a problem that is really need focus, then you can start with that one. Like to identify a really a particular problem that is that deal with electricity generation or distribution or demand side management. You need to identify one problem first, then you can start with that one. And yet definitely future is there. So you just need to identify a problem and think critically, is it really a problem or not.
There's a question from Shariar Ahmed. Can you tell me the future prospects for solar energy? Can we add 30% of total energy supply from solar energy?
uh, Actually, the main we can do that, like 30% from solar we can do that, but there are some challenges. The first challenge is that you don't have that much land. Do we have land that we can install solar panel? Because you need to have, like, if you want to install just 1 megawatt power plant, you need huge land. You can check the recently installed power plant in Kaptai and some other places. There might be two or three, and then I mean they installed it or acres of land. Money, I mean it's huge land. They require huge land to do that. So if we can ensure that we have sufficient land, then we can do that. But another way to do it is the rooftop installation. So if we all install rooftop solar panel, then that might be possible. But in that case, government initiative is really important.
There's many appreciations.
Thank you, Ridwan.
Suvi Shorkar, happy to see you, Imran sir. It's from Banuddin Bhoya. Nice to see our respected Imran sir.
Thank you.
From Redwan Ali, very informative discussion. Happy to see our honorable sir. From AR Leon, very informative sir.
Thank
From
you.
Muhammad Rasel, informative. Maybe Hassan email, enjoying an informative discussion. Another from Distribution. Happy to see you, honorable sir. Shahriar Ahmed, thank you, sir, got it.
Thank you.
Maybe that's it. There's another question from Mohammed Bhuya. Sir, how can we relate today's emerging technology like AI and deep learning to achieve smart and sustainable energy sources in electricity generation sector?
Okay, that's another nice question. If you really want to integrate this AI, artificial intelligence, in sustainable energy management or sustainable electricity generation system, there are first you can think about, like, for example, we need to dispatch our generation. Dispatch means we have, for example, we have generation, different kinds of generation. For example, we have generation from hydro, generation from wind, generation from solar, and then generation from fossil fuel. So if you want to make the system that produce less amount of greenhouse gas emission, then you can use this artificial intelligence so that it can decide. So when you are going to use this artificial intelligence, they will consider several factors. For example, if I burn, or if the system burns coal, and if the system burns gas, then coal is going to be more carbon intensive than gas. So that system is considered okay. So this time, for the timing when all the sources are really occupied, then we might use the coal. And for example, at the other time, for just after 10 minutes or 20 minutes, all the sources are occupied, then we can use but hydro is there, so we can use hydro. So these kinds of optimization, so which one dispatched fast, this sort of information, or this type of optimization can be done through artificial intelligence. And that is really another field that can be researched, and I would say, and yes, it has the potentiality. So you can implement this artificial intelligence in demand side management and even electricity generation dispatching.
There's another question from Shahada and Shilpa. When the problem is selected, what is the next step to do? Though I know, sir, you will say that you find the answer of the problem, but how?
Actually, research is the answer is in this word. So you just have found maybe one problem, then you have to research. And for example, you might not get the exact answers. Is there any solution to your problem in the literature? But you might find something that is closely related to your problem. So you can use that one. Okay, if I implement this one or this solution to my problem, how it going to contribute to the overall scenario? Or if you find something that is really like partially it is related to your problem, then you can implement that one and then think about the next step. So these kinds of things, it's not like that you don't know anything and then you need to start from the zero level. It's not like that. So when you identify a problem, try to identify some solution that is not exactly your one. If you find exact solution, then it's not going to be a research. So you need to find out a solution that close to your problem, and then apply that one in your problem. If it is possible to solve, then you can say this is the solution. If it is not, then use that portion and then design similarly the other portion that is required to solve the overall problem. So that's the point. I mean, you don't need to start to solve the problem from zero. You always have something in the literature, so you need to search the literature to identify the solution. At least you can have some clue. You will have some clue in the literature. So that's the answer of your question.
There's a appreciation from Mr. Guptas. Thanks for nice presentation.
Thank you.
That's my question. Maybe we have just answered this question. Oh, okay. Thank you, sir, again for your valuable time. Also, thanks to the audience for your participations and making this event successful.
Thank
There's a
you.
short announcement. Our next program is how to avoid paper rejection. and addressed reverse comments beautifully and successfully on 24th of April 2021. And to know more about our next program and to get updates on our activities, follow our page, join our group, and to get the recorded video, subscribe to our YouTube channel, MD Sabi Hussain. In addition, we are happy to inform that we are now a family of more than 23,000 members, including group, page, and channel, within 9 months only. Stay with Gausha Bhattacharya, research and BD, and invite your research enthusiast friends to our platform. Wish you all the success and good health. Allah Hafiz.
Thank you. I love it.
Thank you so much.